Hello everyone, welcome to Reactify Labs. Today I'm going to talk about something called API response time. So this uh, is a good topic for your discussion during your high level design interviews. So it is possible that you may be asked to build a game or a chat like system like WhatsApp or a video streaming platform, and somebody may ask about your choice of database or servers, and this topic may come up that what would be your API response time if you choose this particular database or this particular server or this particular algorithm for load balancing. So that time you can explain it clearly if you know what API response time is. Okay, so what is API response time? Um, so API response time, by definition, if you see it, it is nothing. It's just the total amount of time it takes for an API to receive the request, process the request, and send the response back to the client. Okay. So uh, before diving deep into what this actually is and why are we discussing it, let's understand with an example, and also understand two things. One is API response time, and there is one more thing called API latency. People often get confused between them, but okay, let me explain why, what the fundamental difference between them is with an example, and this will be clear to you, and you will never forget it. And I will also make an equation between them. Okay, so what happens is, um, let's say you go to a restaurant. Okay, you go to a restaurant, you sat on a table. You, on a table means you sat on a chair, obviously. You look at the menu, and you start ordering. Okay, waiter takes your order. Waiter goes to the kitchen. Then what happens? Waiter is not going to cook it for you. Waiter tells the chef. Waiter informs the chef about your order. Then what happens? Chef prepares it. Once the chef has prepared your order, chef informs the waiter. Then the waiter takes your order. Takes your order from kitchen to table. Next, mm, waiter serves your order. You eat. So that's it. If you see, there are too many things involved here. Similarly, what happens when you send a request to server? What happens is your request goes through multiple nodes. Okay, this is a similar analogy. You prepare your request, you send your request, and uh, your request goes through multiple hoppings through different nodes, and then it goes to the server processes it and then sends it back. So this is a similar analogy. So here, if you see, in all these steps, when the waiter takes your order, after the waiter has taken your order, like at this step, okay, from here till here, till here, till here, till here, and till here, waiter serves your order, waiter starts serving your order till this point, till the beginning of when waiter starts serving your order, and from when this waiter had taken your order. This time is the API response time. Okay. And what is API latency? API latency is, I'll use a different color for API latency. So API latency is waiter goes to the kitchen and waiter informs the chef of your order. Okay, from here till here, and then the waiter takes your order and serves you till here. This much is the latency, and this entire thing is your API response time. Okay, I hope this analogy is clear. So basically there is an equation between API response time and API latency, and which is API response time is equal to the sum of API latency and the time taken by server to process the request. Time taken by server to process the request. That's it. Now you will never forget this. So this is an equation, you already know this. Okay, now if somebody asks what's the difference between API response time and API latency, you will not get confused. You will remember that, okay, in the equation API response time is a summation of something and API latency, and something is just the time taken by the server to process the request. Okay, I'll add a few more things to it, like why API latency or API response time is important. Because API response time is completely directly related to user experience. Okay, if there is a significant delay in API response time, then user experience is bad and users are going to shift from your service to somebody else's service. For example, now we see that if you have noticed, when you send a message on WhatsApp, and blue tick, sorry, not blue tick, single tick means the message got sent, it takes some time. Even if it takes 1 or 2 seconds, you start questioning if your network is right or not. That important is this API response time is. You want it to be quick. So in terms of this chatting applications, 1 second is acceptable. Okay, but let's assume that you are playing game, online video game. At that time, 1 second is not acceptable. At that time, the acceptable API response time is 0.1 seconds. So this is the importance of API response time. Depending on what kind of application we are using, API response time is important or not. So let's take an example of a system where, for example, you have used online some things like, let's say, you have to get some data, query something or query a database. At that time, it might take 5 seconds to 10 seconds. So that is fine, because there is a huge amount of data, and that is acceptable because no service is going to quickly yield these results in 0.1 second or 1 second. Everything is going to take time. But let's say tomorrow there is a competitor comes in the market who says that we can give you the response in 1 second. Then it is possible that he will acquire more customers. He will snatch away the customers of other people if they do not work on improving their response time. That's why services like WhatsApp, Instagram, games, online games, these work continuously to improve their API response time. So that's it. Also, let's see one more thing. What decides the API response time? So if you see what I told you, uh, request, the waiter goes from your table to the kitchen. Okay, does something, chef does something, and then waiter comes back from from the kitchen to your table. So it's like your request goes to server and response comes from server. So if these are very far apart, then this time will be a lot, right? This time will be a lot. So we do not want that. So distance between client and server impacts the API response time, so it has to be less. Okay. If your load, for example, let's say you have ordered 10 different types of dishes or 100 different types of dishes, obviously it will take more time than, much more time than if you would have ordered only one dish. So it means it also depends on your payload. If your payload is a lot, the API response time will be a lot. So to reduce the API response time, you have to reduce your payload. Okay. Okay. Now let's say there is one more thing, that if, for example, your waiter does not directly go to the chef, what your waiter does is he tells some other waiter, he tells some other waiter, that waiter tells some other waiter. So that, in that way, the request has to go through multiple nodes. So at that time also the response time will be a lot. So we have to minimize that. What? Proxy servers. So proxy servers have to be less. Okay, let's say everything else is fine, your payload is less, distance is also less, only one proxy server is there. At that time, are you guaranteed that your food is going to be quickly, going to be available to you quickly? If you go to a restaurant and you just place your order, you said I will just eat one noodles, one plate noodle, will it be fast? If all these things are low, like there is only one waiter, there is only one order, and the distance is very less between waiter and kitchen, your table and kitchen. Let's say you go and sit in the kitchen itself. Maybe not. There is one more thing, which is called load balancer. Because it is possible that you have ordered only one thing, but there is only one chef and there are 100 people like you have ordered. So your request will be served in the order, right? So if they had multiple chefs, let's say if the restaurant had 100 chefs, so 100 people can be served quickly. One person, one chef. So a good load balancer and a good load balancing algorithm is also required. So these are some of the important factors to consider while deciding API response time, how to keep API response time low. Also, one more thing, let's say you ordered noodles. You came to the restaurant today and you ordered noodles. The chef prepared it. You came again tomorrow. You came again the next day. If you keep coming every day, the waiter will realize that, oh, you always come to the restaurant at this time and you order this thing every day. So what that person will do is he will already create it for you. It might be a waste, but it will improve your user experience. If it might be a waste if you don't show up, but if you show up, it will be a good user experience for you, that your food got served quickly. So what is that equivalent theory? It's cache. So use of cache is also good in that case. Okay. So these are all the things which improve the API response time, and I believe I have covered almost everything which you may require for a system design discussion. So that's it. Thank you for watching. Please remember to like, share, and subscribe. I will see you in the next one.